Hi, in the last session, we worked upon 7 segment displays. We designed a single bit counter that counts from 0 to 9, and then we will implement it on FPGA board as well. Now, we will discuss one of the most important technique in 7 segment display, and that is widely used when you're working on more than one 7 segment displays. So let's consider that you have these 4 7 segment displays means you can display upon 4 digits on it, right? And for that, you will need 8 multiplied by 4, means total 32 output pins for 4 7 segment displays, right? This actually can do, but this is not a practical solution. So here we will use 7 segment multiplexing technique, and you will surprise that you can operate these 4 displays with just 12 number of output pins. But this is not easy to do because there are a lot of synchronization required to perform this task. So let's understand the technique first. So you can see in this diagram that we have 8 LED output pins, which will drive each segment of LEDs like we discussed in the last session. But the difference is that these 8 LED pins are common for all of these 7 segment displays. Means these data pins are actually shared by all these 4 displays. So the problem is if you want to display number 0, then all these 4 displays will display 0 because they all have same common data lines. So if you are sending 0 through these pins, then you will see 0, 0, 0, 0 in all the displays. And if you send 1, then all these 4 displays will show number 1. But we don't want this, right? Because we might want to see different numbers in all these 4 displays, right? For example, I want to see 2, 4, 6, 8. Means each display showing different numbers. So how it is possible? Confused? So let's see how to do this. Okay, so if you notice, then you will see few additional pins here. These are anode 1, anode 2, anode 3 and anode 4. Now this anode 1 is actually connected to the anode pin of first display. Means the anode pin of all the LEDs of this first display is connected to this anode 1. Same way, this anode 2 is actually connected to the anode pin of second display. Means the anode pin of all the LEDs of this second display is connected to this anode 2. Okay. Same way, this anode 3 is connected to all the anode pins of this display 3. And anode 4 is connected to the anode pin of display 4, right? So let's see how it works. Now suppose we want to display digit 1 on this rightmost display. So what we will do that we will send the data of digit 1 from these data lines. And now it is captured by all these 4 displays, right? But what we will do that we will only select this rightmost display to show the digit. And we can control this by using this anode 1 pin. Means we will send logical 1 to this anode 1 pin. And all other anode pins are logical 0. This means that whatever the data we are sending over these data lines, it will only be displayed on this rightmost display because we have selected it by using this anode 1 pin. So this is our step 1. When we select display 1 and we get the number 1 on that display. Now we have total 4 steps in it. 1 step for each display. So step 1 is done and we displayed digit 1 on this rightmost display, right? Now step 2 means it's the time for this second display and we wanted to see digit 2 in this display. So first we will select this anode 2 pin, means this anode 2 pin will set to high and rest of the anode pins are set to low. Means our display 2 is powered up and rest of the displays are powered off. So we will send digit 2 data now over these data lines. means now our second display will show digit 2. Now step 3. Suppose we wanted to see digit 3 in this third display. So the steps are same. We will select this display number 3, means we will power up this anode 3 pin, and we will power off all other anode pins here. Means anode 3 is logical high and other anode pins are logical low. And now we will send the data of digit 3 from these data lines. So this third display will show digit 3. Same process for step 4. Now we are displaying digit 4 on this fourth display. So select this anode 4 pin and power it up by giving logical high to this pin and logical low to all other pins. Now send the data of digit 4 through these data lines and it will display digit 4 on this fourth display. Okay, so till now it looks good, right? Because we can see each individual digit on this 4 displays. But there is a problem. You know what? The problem is that you can only see one digit at a time. Means either you can see this first display which is displaying 1, or you can see second display which is showing 2, or you can see this third display which is showing 3, or you can see this fourth display which is showing 4. But you can only see one digit at a time or one display at a time, right? Because we are controlling this, that which display should on at any specific point of time. And we want to see all the digits at the same time from all these 4 displays, right? For example, from the data we have given, what we will see? We should see the number 4, 3, 2, 1 like this, right? And to achieve this, we need a trick because theoretically it is not possible. So what we will do, that we will display these digits repetitively and at a very high speed. So if we are displaying them repetitively and at some good speed, so they will be looked like that all the displays are on and showing the digits. So let me explain that what is happening. So focus on this first display. This is showing digit 1, right? So what will happen, that this digit 1 will be flashing many times within a second on this display 1. Same, this digit 2 will be flashing many times within a second on this display 2. Same, this digit 3 will be flashing many times within a second on this display 3. And same for digit 4, which will be flashing many times within a second on this display 4. Means all these 4 steps which we have discussed are repeating at very high speed. For example, you are switching them at millisecond or at every millisecond. So this is really fast. So all these 4 displays are showing the digits many times in a second, and our eyes cannot segregate them at such high speed. So it will display like all the displays are on and showing the digits. Well, this is the concept that is being widely used in almost all type of displays, not only on 7 segment display. Okay, so let's wind up this session. I hope this is an informative session, and if you understand this concept, then please try to implement a 4-digit counter into a FPGA board, which will count from 0 to 9999. And let me know if you're facing any difficulty in logic, and I will record a session if I get multiple requirements for it. Okay. Okay, so that's it for today. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.